Hi to members of this channel and those of you who are getting to this channel for the very first time. My name is Buxton and here we learn from the channel called Construction Surveying Tutoring Channel. What we focus on is estimation and surveying depending on how you like to refer to it. Over the past few sessions, we've been talking about estimation of underground water tank. And today for this very session, I would like us to handle waterproofing and also finishes work to underground water tank. Let's get into it. According to what the items we've learned, and also based on this particular drawing, there are a few items which are essential and should be taken note of by whoever is doing the estimation. Those among the ones that I've mentioned is basically waterproofing. As you all know that whenever you are doing waterproofing for underground tank, or rather when you're constructing underground water tank, it's very essential that you make sure that the waterproofing has been top notch. Otherwise, it won't serve. So whenever you're estimating waterproofing, a few items or a few areas that you will how you will organize your work include the floor surfaces. Floor surface, for instance, in this case, go to the plan. This is the plan that we have been using for that estimation. And also, for those who are getting into this channel for the first time, these videos are sequential. So if you need the background of all the items that we've been talking about, please on the playlist that has also been attached to this description of this video, you will find the rest of them and the rest of the other videos so that you build your knowledge in that order. So we'll start with the floor surfaces and waterproofing to the floor surfaces. That would be interpreted, or you will take that dimension straight away from the plan. The unit for measurement of that is square meters, and according to the plan that you're having, you take that dimension internally. All right, so like in this case it's the floor surfaces, so you just do an equal sign and then you have it as a 3.6 multiplied by 1.6. Okay, so the 3.6 is the internal length stretching that way, while the 1.6 is the internal width. So the two dimensions taken internally should give you the square meters of the waterproofing to be done for the underground water tank. And as usual, because we are doing all our calculations on the Excel here, therefore I would show you also that you can round it up so that you don't have your answers in decimal points, or rather, according to the rules of measurement, you always need to take it to the one what you transfer to the bills of quantities should always be to the nearest large to the nearest whole number. So therefore you can round it up. When you round it up as in this order to the nearest zero, then it means it's going to be a whole number rather than having decimal points in that regard. So that's the floor surfaces. That is all you need to do. Go to the plan, foundation plan, take the dimensions internally, and that is done. Moving quite swiftly to the next item, that is wall surfaces internally. All right. So that means you go to the height to the section. This is the section of that underground water tank, and the items that you need to look into whenever you are doing this item include the following. First of all, this section gives you the height, all right, but then the length internally you should get it from the plan, and that is why I will copy this item. What I've done here, I paste it here. Once I've pasted it here, then I have the dimensions. These dimensions are the internal dimensions of the tank, all right? But then I need to use the dimensions to get the perimeter internally, okay? So what I'll do, I'll multiply the dimensions by 2, And of course, instead of multiplication sign, I will have a positive sign so that I get the perimeter of that rectangle of this underground tank internally. All right, so it's the length plus the width multiplied by 2. That gives me that. Once I have that done, then I'll be having the total length. All right, and as usual, once you have your total length, you can straight away multiply that with the height. Okay, height of the tank, the entire height of it just at once. So referring to the section, okay, this is section 1:1. When you refer to this particular plan, you can see where the section has been drawn. This is the section 1:1. Then you go to section 1:1 for the height. Okay, so the plan, just to reiterate, gives you the length. So you basically get the length of the perimeter internally, then you multiply by the height of the tank, and the height in this case is 3.7 meters. Okay, so I will take 3.7 multiply by the perimeter of the tank internally. Okay, once I have that, just to make sure that my bracketing is correct, so that is 1 2 3. Make sure that you have three brackets on either side, closing and opening and closing. Okay, so in this case, what do I have? I have 39 square meters. Okay, that is the total length multiplied by the height. Okay, this should give me like 5.2 10.4 times 3.7. Yeah, so that is the total area that I have for waterproofing of the wall surfaces internally. Okay, then the next item to look into is to the soffits of a cover slab. Okay, so area of the soffits of the cover slab for this underground tank will be obtained as follows. The unit of measurement for the same, according to the standard methods of measurements, is a square meters. Okay, so once you have that in picture, then you go ahead and find that area in square meters. So the area of the cover slab will be equivalent to the area of the floor surface onto which the waterproofing was done. Okay, so that would mean I just take what I had calculated initially to be 6. All right, then cover slab externally. Okay, so this one normally is referred to as the cover slab externally, and to edges, and to the edges, or rather to the exposed edges. What that description mean is that normally when you're doing the waterproofing externally, you will do onto the slab, the flat surface of it. Okay, then you also need to adjust for the same for the exposed surfaces. Okay, because in some instances the entire underground tank will be submerged below the ground. Of course, maybe just leaving out the part that is the parts that are for the slab. Okay, just only that portion above the ground. But then that is one instance. In other instances, you find that the terrain on which this underground tank is going to be done doesn't give you a room to submerge the entire to backfill the entire underground tank. Okay, so in that case, for instance, you find that there is like a meter remaining from the cover slab downwards to the wall. Okay, so in that case, for instance, what I mean is that you find underground, the original ground level is up to somewhere here. Okay, for instance, in that case, so that means you have an exposed part of the wall externally that needs to be plastered. So that is why we have combined that description together. So in first instance, just to be sure, your unit of measurement for that particular item is square meters according to the standard methods of measurements. All right. Then you go to the floor plan. Okay. This floor plan gives you water tank foundation. Okay. But then it's not the best that you can use. Rather, you go to the one that is talking about cover slab. So this is the cover slab. This cover slab is the best pick to use when you are measuring cover slab. Of course, you'd understand that for soffits of the cover slab, the soffit doesn't have much of an implication because the area that we are dealing with at the base slab and the area we are dealing with at the cover slab, they are simply defined by the same walls. So basically, they are the same. But then at the top, it's not the case because you understand. In that instance, we are going to be doing it even up to where the cover slab is covering, or to the external faces of the external wall, so to say. Even in the reference of let's just look at this. Even in the reference of the section, you will notice that in this case we are going the entire scope, moving all that way at the top. Okay, so we do it that way, and then at the top going that way. Okay, so what we need to do is to get the dimensions externally. That is the short explanation for that. Okay, so the dimensions externally, I'll just copy my formula so that I have it also here. But now what I'll do is this. In this case, I have 3.6 moving internally, but then now I need to add the parts of the wall so that I have the entire length stretching to the external faces of the external wall of the underground tank. So I will take 3.6, then I add 250 on one side and another 250 on the other side. That is a total of 500. So 500 plus 3.6 should give me 4.1. Okay, so that gives me 4.1 meters for the length externally. Then I also need the width externally, which is 2.1 as indicated here. So I will multiply that times the 2.1. So that should give me the area externally of the cover slab. But then I've brought in the concept of the bit that can be exposed externally. Okay, so in this case, we need to adjust for the same. But how do we do that? So what we'll do is simply add. So on this already we have the area for the cover slab, and then we have a plus. So from the plus, now we get back to our perimeter, but now externally this time round. Okay, so let's refer to our cover slab as we've always done. This is it. So in this case, we'll take now the 4.1 plus 2.1. That gives us 6.2. Okay, 6.2 times 2. Okay, that is 12.4. So I'll take the 12.4 as the perimeter externally, then I multiply that by our assumed exposed edges of walls of the tank to be around, let's assume 1 meter. Okay, so this is entirely based on assumption, or because you don't know how much of it might be exposed until it's done. Okay, depending on the type of soil or the type of terrain you are dealing with. So the entire perimeter is 12.4 meters. You multiply that by 1, which is the assumed exposed height. Okay, you get that. So this will give us that portion, and this will give us the area. Once you have that sorted out, then you take let me see, 1 2 3 4 I need also for this side 1 2 3. Okay, so I need 4. I need the fourth one here. Oh, there's an error. So what I need, let me count again. 1 2 3. Those are 4. 1 2 3. Oh, they are 4. There is a problem. I don't know from where. Yeah, they have the closing and the opening parentheses must be the same. If they are not the same, then you have a problem. So I'm just trying to see which of these is the problem. 2 3. 1 2 3 4. There must be one that I'm not seeing and I don't know which one it is. Let me just find out. Alright, so I've just removed one of them and we are good. So we have 22 square meters there. So that means we've already handled the waterproofing areas internally for all the items that we have, actually internally and also externally. So we started from the floor slabs, we've gone to wall surfaces and then soffits of the cover slab and also internally and also externally. So that is well covered or well taken care of. So we move on to the next item is water insulation. Okay, this is according to my description, but at times you might just wish to call it water bar. Okay, so whenever you're dealing with an item or rather underground tank of this height, then you need to understand that there is the concept of water bar, and the reason is the height is quite substantial. 3.7 meters is high, and a kind of formwork that is available in the market goes up to around 2.4 meters. And what that means is that you will have to do this particular wall in two portions, okay? Because combining them or doing them, or rather combining this formwork to have the complete height is not an easy task. So in that case, you will do the first portion and then you'll get back and do the other portion later on. So in that junction, okay, now we have two junctions. So we have the first junction, you introduce a water bar here, okay? The junction between the base slab and the wall, have the first line of the water bar. And also at 2.4 meters, saying for example, this is 2.4, you have another water bar on this other junction, okay? So that would mean take the perimeter internally, then you multiply by 2, okay? There is a part where we dealt with the perimeter. This is it, the 3.6 plus 1.6, okay? That gives us 5.2 times 2, 10.4, okay? So we have 10.4 multiplied by 2, 20.8. That one rounded up, you get 21 meters for the water bar in those positions, okay? So that said, we move to the plaster because we need to handle the finishes, the waterproofing and also the plaster finishes for the tank. So we move to the floors. Plaster to the floors is equivalent to the area that we've got for the waterproofing, same as the wall, okay? So just have it as equal signs. Then suspended cover slab internally, the same as what we have done here. And then suspended cover slab and edges externally. So that one is also similar to what we have talked about above, okay? So once you do that, then we need to see about the finishes at the top. In some instances, you might have cabro because you can be using that top as a way of using it as a parking or and so on. So if you're not using it for that other purpose, then just the finishing that we've measured above, including the waterproofing and plaster work, should just be sufficient. Unless otherwise, if it's you are using it for another purpose, then you can have an item like cabro works on top of it, and the area for that on the top should be equivalent to the area of the cover slab externally. Okay, and that would be what we are done here. This one was coming to 22 square meters, but then if we added the 12.4 by 1, so leave alone that, just take the dimensions internally, the 4.1 by 2.1. Okay, so what I'll do, I'll just take this. Let me just go. I can take this one instead. Give me easy work. So I'll take 3.6. 3.6. Not really. The dimensions externally is 4.1. 4.1 by 2.1. Okay, that is according to the layout, external, the cover slab layout. Okay, so we had seen here is 4.1, and then this other one is 2.1. So this one should give me 9 square meters. Then of course we talk about backfilling. This is now the return fill and ram of the selected materials around the external surfaces of the retaining wall, or rather the external wall of the tank. So what we have here is equivalent to what we have calculated. So we get to where we did the excavation works. Normally, what we'll do, we'll give an allowance, and the allowance will give in this order or in this manner. Simply take the perimeter externally, that is now the 4.1 plus 2.1, so I make that to be a plus, and I will multiply it by 2 so that I have the perimeter. And once I have that, then I need to multiply it by the width, because I need the length times the width times depth of what we are backfilling. Okay, so what I'll do is the width for that, I will assume that we gave 300. Okay, 300, because you can see the 200 is here, but then there was a smaller portion here. So we'll assume that we did an excavation of 1 foot. Okay, that is 300 millimeters. So this will be 0.3. Then I'll multiply by the depth of what we are backfilling externally. Okay, so in this case, it's the entire stretch, the entire height. Okay, so we'll take the entire height for this underground tank. So 200 add to 3700, that is 3.9. Add to 250, then we add the 50 for the blinding. Okay, so this is 300 plus 3700, we get 4000, plus 200, we get 4.2. So this one becomes 4.2 meters. Okay, let me see if that is okay. Perfect. So we have the backfilling around the wall. Okay, then normally whenever you're doing a tank, then you give provisional sums for plumbing and plumbing services, just to do the water connections, the pump, and so on. Give it a lump sum figure depending on the market rate of those necessary items that I have just mentioned. And also preliminary is quite crucial, just to cover you with, as you do the work, items to do with the scaffolding, water, and so on. Then lastly, testing. Okay, yeah, I can just give a smaller sum for testing, cleaning, and sterilization of the tank. That said, we come to an end of our session, and also we also come to an end of the thread where we were talking about underground tank. So we've done all the quantities, And as noted, there have been a number of requests where you people need me to work about the material schedule. So I will use these quantities to work on material schedule, which is the next upcoming content, unless otherwise there is another request which might precede or might be ranked as a top priority rather than the one I've just mentioned. I want to thank you all for watching up to this point, and I believe these videos are worthwhile. If you find them so, kindly leave a like, subscribe to the channel, and you might wish to go a top notch higher to just become a member of the channel. That will enable me to reach more people, enable us learn a lot, and you also will not be able or will not be in a position to miss such videos that you like a lot. Thank you very much. Stay safe. Till we meet again in our next session. Bye bye.